Alright, so I've got my Canvas shell opened here. Hopefully we are able to see that. And I've got it in something called Student View. So hopefully this will be exactly what you guys are able to see. There's Demography Lab on my to-do list. I don't know if that's on your guys' to-do list. Also, while I'm at it, I'll just go ahead and remind you, don't forget to do that discussion question if you haven't done that yet. Let's go down to week 10. There's your discussion, but here's the Demography Lab. I'm just going to click to open this up, see what we get. There we go. Please download. The assignment's due before Thursday before midnight. It's actually due Sunday before midnight, but that's okay. It says it right there. Just click download this. And I'm just going to put it directly into Docs because I like Docs a lot more than Word. You guys can use whatever editing software you have, like LibreOffice or OpenOffice or like whatever you want. It doesn't matter to me. For the spreadsheets, though, you really need to be using Google Sheets because otherwise it's not going to be super easy for me to like instruct you, tell you what to do. So open, we'll go upload, loading. I should be doing this with spotty internet, but okay. So here's our demography sheet we're supposed to be working through. And it describes all of the statistics up here for these life tables. And here I created these images that show you the equations for each one. Again, some of you might find this useful. I personally would probably find it more useful to just develop a slightly more intuitive understanding of these things rather than memorizing formulas or whatever. But let's go through here, and I say copy the data from the link below into a new Google Sheet. So I'm just going to click this. We'll open this up as soon as it loads. So there we have it. This is our first life table here. I'm just going to go sheets.new, which is going to open up a new Google Sheet for me. And if you actually click in here and you just press still loading. Bad internet. Okay. It's doing something. So if you just click in here and you press Control A, and then press Control C, and you go over to your new sheet here, just paste the data in, and there it is. Excellent. So now let's go through and talk about each of these statistics in context and talk about how to calculate each one easily, hopefully, using Excel. So this first statistic is survivorship. Okay? It tells us the number of individuals who survive from one generation to the next from the original starting number. So this is N of X divided by L of X. So how do we calculate it here? I think I flipped it. To be X divided by N of L. So this is going to be equal to D5 divided by D5. Because we have, of course, we have 100% starting. What the heck? Oops. I'm working in the wrong sheet. Somebody just saw me do that. That's kind of fun. Shout out to whoever's on there. Equals D4 divided by D4 because we have 100% survivorship. I'll close this now. We have 100% survivorship in the first generation. Okay, so how do we calculate survivorship for the subsequent generations? Well, it's going to be the number alive in that generation divided by the number that we started with. So in this case, I'm going to say equals D5 divided by D4, okay, which gives us a very, very low survivorship number. And that number should make some sense to you, just given the fact that we went from like 1,200 down to 86. All right, and we can do this again. We could say equals D6 divided by D4. And we could just keep on typing all of these out again and again and again. I don't feel like doing that, but if you're not on board with what I'm about to do, it's perfectly reasonable. It'll only take you a minute. Not a big deal. Just go ahead and keep doing that. But I'm going to go ahead and say equals D7 divided by, or slash, D $4, rather. And what that $sign does is when we click and drag this formula down, like we've done in lab together, where you go to the bottom corner, you select the cell and you go to the bottom corner and click and drag it down. It drags the formulas, but it still keeps that $sign that you put, it keeps it the same. So, like, let's say I was going to go over here. This is not what we're going to do, but I'm going to say equals E4 divided by D4. If you were to drag this down, it would give you wrong numbers. Okay, anyway, neither here nor there. So I'm going to go ahead. You can keep all of the sig figs if you want. Oops, I don't feel like keeping them, so I'm going to just select all these. Go up to the top and click decrease decimal places. Obviously, we need some decimal places, but that's fine. Okay, what's the next statistic we're going to calculate? D of X, or the death rate. This is the number of individuals that are dying during each time period. And the way we're going to calculate this, let me zoom in a bit easier to see, is we're just going to take the number here and we're going to subtract the number below. So this is going to be equal to D4 minus D5. Which means that between this generation and the next generation, 1,182 individuals died. Alright, so this particular statistic doesn't require any additional Excel magic like we were doing with the $signs for this one. You could, if you wanted, you could just continue typing it in. And Sheets already kind of knows what we want to do here. It's wrong, but it tried. We're going to take equals D5 and subtract D6. Because again, this is the number of individuals that died in this generation. We could just keep doing this. We could say equals D6 minus D7. But I don't really feel like doing that. So again, I'm just going to take the cursor to the bottom right-hand corner until it turns into a black cross like it's doing. And then I'm just going to drag it all the way down. And there you go. Okay, this is the number of individuals that died in each generation. Now we're going to calculate what's called the age-specific death rate, the rate at which individuals are dying in each generation. The way that we do this is we take the number of individuals that died, age-specific mortality rate. I've been saying death rate. It doesn't really matter as long as you understand what it means. You can call it whatever you want. This is equals F4 divided by D4. So the number of individuals that died in that generation divided by the number that you started with. Okay, 93% age-specific mortality, which is fairly huge. Yeah, think about that. If the number of human individuals that died between the age of like being a baby to being a toddler was 93%, it'd be bad, but it isn't, thankfully. So. All right, let's keep calculating these. We're going to say equals F2 divided by, F5 divided by D5, because it's the number that died in this generation divided by the number that we started with, 2% or something like that. Let's just go ahead and again, I'm going to click on the formula that we just wrote. We can even do it up here. Click on the formula that we just wrote, take the cursor to the bottom right-hand corner and just drag it down. We don't need to do any $signs or anything special with it. Get rid of that because it's nonsensical down there. And a couple less decimals. And there you have it. That's the basics of a life table. There's a lot of other stuff that you can incorporate if you are so inclined, but for our purposes, this is enough, at least for right now. Delightful. So let's see what I've asked you to do for this one. Calculate LX, DX, QX for each time period. We've done that. Create a survivorship curve, which is the generation time versus survivorship, and an age-specific mortality curve. So, all right. Oopsies. All right. Sorry for the discontinuity. Pretend you didn't see that. So I'm just going to go ahead and select all of these x values here. Okay, that's our generations. You want to include x in this when you select it as well. That's going to help Excel to be able to graph it. And then I'm going to press and hold the control key while I'm selecting the data in column E. Okay, because what this wants is, again, pretend you didn't see that, x versus L of x. So we have x here selected first, L of x selected here. The next thing you do is go Insert, Chart, and this is pretty much what we want it to look like. L of, actually, yeah, L of x versus x. Did I flip that? Yeah, I did, but that's okay. This is what you want it to look like. So I'm going to go ahead and press Control C, or what's better yet, let's go Edit, Copy. We'll go over to our Excel, or our Word doc rather, Edit, Paste. We'll want to paste unlinked. Generally, you always want to paste things unlinked. And there you go. It doesn't really matter what size it is because it's all going to be digital. You won't have to print these things out. But there you go. That is our survivorship versus generations. And you can see it starts off very, very, very high. Survivorship is high and plummets immediately. So this tells you quite a bit about sort of the life history choices, which is something we're going to get to in the next section. Oh, and I guess I asked you to do all this for each time period. So we'll go ahead. We don't need this anymore. I'm going to go ahead and copy this chart as well. So you can just select all of the pertinent data and go to Edit, Copy, go back over to where you need to paste it. We're going to go Edit, Paste, Paste Unlinked. And there you go. Here's our filled out life table. I'd like you to paste these things in so I see that you've actually been able to do them. But there they are. Here's our graph. And now we have to calculate, or not calculate, but we need to create a graph for x versus q of x, or the generation versus the age-specific mortality rate in each generation. So again, I'm going to go ahead and just click here, select all of these data, get myself out of the way, and then press and hold the control key. That's what I'm doing right now. I'm pressing and holding control and just clicking here and dragging down. Now sometimes people will do weird stuff where they'll click on this beforehand and then accidentally click here and then they'll get weird. So just click on it, press and hold control, drag it down. You can select the other way too. We'll do it like this. Hopefully that doesn't mess things up. We'll see what Excel does. We'll see what Sheets does. Insert our chart. And there you have it. This is our age-specific mortality rate. And again, these things, it starts off very, very high, and then it maintains a somewhat low level throughout the middle life of these organisms, and then increases rapidly at the end as they get toward the end of their lifespan. So I'm just going to go ahead and do the same thing we did before. I'm going to go Edit, Copy. Just go ahead, paste this one in. Unlinked again. Cool. Paste those graphs into a Word doc along with the following questions and answers. Apart from generation 21, which generation has the highest age-specific mortality rate? Well, that would be the first one. You can corroborate that by just looking back at your data as well. The first generation is 93%. So again, this is some infant die-off, like maybe eggs aren't hatching or are being eaten before they can make it to the ocean or whatever. And then this one is just old age. All of the other organisms have just died off throughout time. So the answer to this, and I do appreciate when you guys do stuff like changing the color, so we could do like dark gray. I didn't mean to highlight, I meant to change the color. Yeah, we'll do light gray. And I'll let you guys answer that. what does this tell you about the population? Well, I kind of said that a few seconds ago, so if you could rewind that a few seconds, you can figure out kind of where my thinking, where my thought process on this one is. It tells you that organisms are dying off very early in their life, and all organisms die eventually, no matter what kind of thing they are. All living things will die. Morbid, sorry. But what this means is that there's a high infant mortality rate amongst whatever organism this is. And this is kind of the same question. How many individuals died between generations 0 and 1? So what it's asking for is the D of X statistic for this here. So you put that number in, and what does that indicate about the population? Well, that number it requires some context, so it actually indicates less potentially than the age-specific mortality. It's kind of like this. If I told you, I ate 100 apples, okay, over what time period? Or even better, 100 apples were eaten. Okay, well, what does that mean? Who ate the apples? How many people were eating the apples? How much time did they have to eat the apples? Okay, so this does indicate something about this population, but it definitely indicates less than our other statistic. All right, let's see if we can go get this next spreadsheet here. Loading. Working. Just going to copy this. And I'm just going to go ahead and get rid of that because I don't need it right now. Paste this in. Cool. Didn't mess that up, I hope. Shout out to Anonymous Green Octopus, or whatever that thing was. All right, we're going to just do the exact same statistics that we did before. This is D5 divided by D. I'm going to put a $ here to do my neat little Excel trick. And there you go. D of X is, again, just the number that died in one time period between generation 1 and generation 2, how many organisms died. I'm just going to go ahead and click and, oops, I missed. I'm just going to click and drag that down. And Q of X is the number of organisms that died in that generation relative to the number that you started with. So this is equals F5 divided by D5. Go ahead and drag this down. Rid of that. So I'm going to press, oops, geez. I'm going to go ahead and press Control A. I'm going to go Edit, Copy, and we'll just go ahead and it didn't actually ask you to paste in this data. I see that. I didn't realize it didn't ask you to do that, and that's okay. You have to. You have to calculate those things either way, because in order to create those curves, it's just something you have to do. But let's go ahead and create our survivorship curve and an age-specific mortality rate curve. So I'm going to go ahead and select all of my X values. Then I'm going to press and hold the Control key and select my survivorship values. And then I'm going to go ahead and go Insert a Chart. And there you have it. This is kind of a cool looking chart. It tells us some potentially interesting things. Copy this. Once again, unlinked. There it is. This is our second population that we're observing. What else did it want? Survivorship and age-specific mortality. Don't need you anymore. Go ahead and select our X values. And again, press and hold Control and select our age-specific mortality rate. Insert. Same chart. Interesting. Just go ahead and copy this. Paste it in here. Again, we are pasting unlinked. Cool. All right. So paste those graphs into a Google Doc. How is survivorship different from this group to the first group in the first question? That's awkwardly worded. Sorry. So I mean, how is it different? Let's look at the two. So here's our survivorship rate. Oh my goodness, what just happened? the wrong button or something. So here's our survivorship curve for this generation, and you can see it's relatively stable. It's sort of on a downward slope until you get to between generation 5 and 6, and then survivorship just plummets right here, just tanks. Whereas in this one, survivorship is it tanks immediately. So very early in this organism's life, most of the individuals in this cohort are dying, whereas in this organism's life, they're waiting till around the 5th time period, whatever that happens to be. Maybe it could be 50 years or it could be 5 years. It just depends on what kind of thing you're looking at. So, yeah, that's what I'm asking you to do there. Compare survivorship from this question to the previous question. Create a graph of X versus, or generation versus the number of deaths. So I actually did graph let's see, let's go ahead and make that graph really quick. So select these. Select this. Insert a chart. All right, cool. This is our chart. I'm going to go ahead and again, we'll go edit, copy. Just go edit, paste. So this is kind of an interesting comparison, right? Because this is our age-specific mortality rate, whereas this is our age-specific deaths. This is the number of deaths. So how are these two things different? How are the statistics different? What does this chart tell you? This chart tells you the number of organisms that died relative to the number that you still have. This chart just tells you the number of organisms that died. Okay. This one, it provides you with a little bit less context, but I'm sure you guys will be able to figure out a good answer for this question. How is this different from the chart that you created above? All right, our last sheet here, we're going to go ahead and see if we can get this one. Go sheets.new. It looks like I've filled this one out for you guys already for our two populations. Loading. Is my internet dead? No, okay. I'm just going to press Control A and Control A again. Shout out to Anonymous Capybara. Cool. All right. Create a survivorship curve and an age-specific mortality curve for both populations. So let's go close this out. Here is our generations. I don't know why this 0 is down here. I'm going to go ahead and get rid of it. Okay, so we'll start with survivorship for generation, or for our first population. Select all those, press Control. Select all those, insert a chart. There we go. And I'm going to go ahead and edit this and just say population 1, just so that it's easier for me to keep track of. Paste unlinks. And I'm going to make this smaller so I can like put them right next to each other. And let's go back, make it for the same chart for population 2, which is over here. I'm going to select all these guys. And then press and hold Control and select all these. Insert, chart. There we have it. Control C or edit copy. We'll go in here. Edit. Paste. Did the wrong thing. Edit, copy. Paste on links. All right, things a little bit easier for us to compare. If you don't feel like messing around with that, don't necessarily worry about it. It's totally fine. But you do need both of these graphs here. So that was our survivorship curve. I think we still need to make an age-specific mortality rate. You can already see these are very different. So let's go ahead and make our age-specific mortality curve for population 1. Select all this. Press Control, select our age-specific mortality rates. Insert a chart. There we go. I'm going to go ahead and also just throw on population 1. All you have to do is double-click on that title to edit it. It's going to make your life a little bit easier, probably, if you're like me and I tend to forget what's what. Age-specific mortality curve for population 1. We'll go ahead and grab that same data, graph that same thing for population 2. Remember, press and hold Control. We'll get this stuff. Insert a chart. And I guess I should be consistent. I wasn't consistent above, but it's fine. Go Edit, copy, go Edit. Let's make sure they're both on there. But we've got them there. Really, they should be down here below number 2. If you could put them there, that would be helpful. All right. These data represent 2 populations of the same species. What is the difference between these 2 populations? Well, you could probably figure it out just by glancing at this. You see that the mortality rate is very high, very, very high initially in this population, whereas this population is very low until they start to get really old. And then they start dying off more. This last data point actually probably shouldn't be included because at generation 16, no one is alive anymore, so it's implying that there's 0 deaths, but of course it is, because nothing's alive here. Let's just be cheesy. There we go. There. Fixed it. So there you have it. That's the difference between these 2 populations. You might be able to figure out some other things. What does it imply about life history trade-offs between these 2 groups? And what I mean by that is a life history trade-off can be something like, when do you reproduce? So if you are in this population, when do you think you have to reproduce? Versus if you're in this population, I mean, if you're in population 1, are you ever forced to reproduce when you're young? Before you get to generation 14 and everybody starts going away, are you ever forced to? I don't know. It's questions for you guys. What do you think of the QX of individuals in the United States was like before the advent of vaccinations versus after? So if you go back to, I don't know, we'll say the turn of the century, you go back to 1900, people were dying of polio, people were dying much more commonly of the flu. So what do you think the age-specific mortality rate of humans was like in the U.S. before we invented vaccinations? You might even be able to look it up. When you're done with this, please submit the docs as your demography lab assignment on Canvas, okay? And so what I want you guys to do is type in all of these questions, paste in these graphs. I really would appreciate it if you would leave the questions where they are and then type your answers in here. You don't need to actually type this is my answer for 3A, but just leave the questions where they are. Type in your answers. If you wouldn't mind changing your font color, that's extremely useful for me. If I was smarter, I would just change my font color, but I don't want to mess things up, so I'm going to leave it. But there you have it. That is how you do pretty much all of the steps of the demography lab. If you have, and that's specific, I already recorded a video, but maybe wasn't specific enough. If you guys have more questions, please let me know. Cheers.